Okay. The other part of drawing or graphing a linear inequality that I have to include is a region called the half plane. Okay, the half plane is a shaded region on the graph above or below the boundary line. Okay, so above or below the boundary line. The inequality sign that's in the linear inequality tells us which region to shade. Okay, it tells us that the possible values of x and y either fall on the boundary line, okay, if we have an equal possibility of being equal, and or on one side of the boundary. Okay, so it looks like this. If we see either of these signs here, so let me give you one other one as well. So if we see y as greater than or y is greater than or equal to, we are going to shade above. Okay, we're going to shade above. So if our graph looked like this, let's draw. Okay, I'm going to simply sketch in two boundary lines here. Okay, imagine that we went ahead and we had a linear inequality and we graphed the boundary line like this. Okay, if I see that it is greater than or equal to, I'm going to shade above. So that will look like this. Okay, this above that line is one of the half planes. So what's happened here is that our boundary line has divided our Cartesian graph into two planes. It's divided the graph right in half. And so we'll either shade the upper half plane or the lower half plane, okay, depending on what our inequality sign tells us to do. If we have this inequality sign here, less than, or y is less than or equal to, that tells me that the possible values of y are below, okay, or in the second case here, less than or equal to, below or on the boundary line. And so if I had the same boundary line here, okay, when I see an inequality sign that tells me it's less than or equal to, I'm going to shade below the boundary line. So I'm going to shade the lower half plane. Okay, let's go back to the last example for a moment. I'm going to get you to flip backwards one page in your booklet. Okay, so that we're having a look at that graph that we just drew. And now let's have a look at what side of which half plane we should shade for this example. Okay, so here is our linear equation up at the top. Pardon me, our linear inequality up at the top. Okay, there it is. Okay, so we drew the boundary line as the line y equals 2x plus 3, and now we have to decide which half plane to shade. And I see, okay, that my linear inequality says y is greater than, so I'm going to shade above the line. Okay, so I'm going to shade above the line, so everything to the left of the line here. Okay, above the line. I'm not able to shade very well with my pen right now, the way I'm drawing it, but if you're doing this at home, you can take your pencil and actually shade it right in. And if you have a look in your textbook in chapter 6, it will give you some examples of graphs that have been shaded in. If you have a pencil crayon as well, that's a great way to shade it, or just lightly shade it with your pencil. Okay, you're welcome to shade it the way I have. That's sort of a fast and easy method. Okay, just drawing lines. Okay, let's flip ahead a little bit more then. Let's do some other examples. Okay, so 2 pages forward, let's do this example right here together. Okay, so here I have a linear inequality. I know it's a linear inequality because I have a inequality sign in there. I don't see an equal sign. So I can start by drawing the boundary, and the boundary for this inequality will be the line y is equal to 2x plus 3. Okay, that line's going to form the boundary of my inequality. I have to ask myself, is this line going to be dashed or solid? And all that information comes from the inequality sign. So you look at this inequality sign and it tells you two things. One thing it tells you is that because I see that equal sign underneath, this tells me, okay, to use a solid line. If it was y is greater than 2x plus 3, I'd use a dashed line. Okay, but it's greater or equal to. The other thing it tells me is that after I've finished drawing my boundary line, I see that y is greater than 2x plus 3, so I'm going to shade above the line. Okay, so that inequality sign tells me two things. Let's go ahead and graph this. I can start with my formula y is equal to 2x plus 3, because that's going to be my boundary. That's my y-intercept. There's my value for b, so I'll start there. I'm going to graph this in blue. And let's go to the point 3 on the y-axis, which is right here. 1, 2, 3. Okay, there's my value for b. And now the slope is given to me here. The slope is 2 over 1, which tells me that my rise is 2, so I go up 2 and I go over 1 in the positive direction. Okay, so from my point B, I go up 2 over 1, up 2 over 1, up 2 over 1, and I can connect those lines. I'm not given any restrictions for this question, so I'm not told that x or y have any limits, and I'm also not told that they're integers or whole numbers. So I'm going to assume that x is a member of the real numbers. I'm going to assume that y is a member of the real numbers. So I'm going to assume that this line, okay, or this solution set is continuous. So I go ahead and I connect those dots with a solid line, okay, and I'm going to show that it's continuous. And I'm sorry I'm not drawing this very straight. Hopefully at home you're drawing a little straighter, you have a ruler. Okay, and then the next thing I do after I've drawn my boundary line is I have to shade it. So I'm going to shade the region above the line. Okay, so I'm going to shade this half plane right here. Okay. Let's do another example. We're done for now. We are going to come back to each of these graphs and just talk about all the possible solutions for this graph. Okay. Let's do this one right here. We've got y is less than or equal to x. Okay. I know it's linear inequality. I also know that the boundary for this, so the first step is always to draw in my boundary line. I'm going to graph my boundary. So I know that the boundary is the line. The boundary is always going to be the line y equals, okay, whatever the right-hand side of the inequality is. So I just simply put in an equal sign instead of the inequality sign, and that gives me my boundary line. So y equals x, and y equals x is written in mx plus b form. Okay, y equals mx plus b. I have y is equal to, well, my slope is just 1. Okay, and my b, I don't see anything there for b, so my b must be 0, my b value. The y-intercept here is 0. Okay, that tells me that's my b value, and I know then that the graph crosses the y-axis right at the origin, at the point 0 on the y-axis. Okay. All right, from there I can use my slope. Okay, my slope is equal to 1 over 1. So that tells me to go up 1, my rise is 1, and my run is 1. So I'm going to go up 1 and I'm going to go over 1. And I'll start with b. So let's start in the middle of our graph in the origin. We're going to go up 1 over 1 and put another data point. Up 1 over 1, another data point. Okay, and you can do this. You can do this in the positive direction. You can also do this in the negative direction. You just have to think about it. You've got to go down 1, back 1 if you're going to put a point before B. Okay, and you can do as many of those as you like. I see here that I have no restrictions, so I'm going to assume, again, I'm going to assume that this solution set is continuous. I'm going to assume that X is a member of the real numbers and Y is a member of the real numbers. Okay, so we don't see any restrictions, so I can make that assumption. That's okay to make. The next question next thing I need to do is decide whether to use a dashed line or a solid line to connect these points. So we go back to our inequality and we look at the sign. Okay, because I have less than or equal to, that tells me to use a solid line. Okay, so let's do that. We connect our data points with a solid line. And I'm going to show a little arrow going in both directions because there's no upper or lower limit here. I have no restrictions on X or Y. The second thing I need to do is I need to shade either the upper half plane or the lower half plane, and I look at my inequality sign and it tells me that Y is less than or equal to X, and the less than tells me to shade below the line. Okay, so I'm going to shade below the line, so I'm going to shade the lower half plane. All right, great.